A clothing company, it says, makes jackets and pants. It gives you a bunch of information. It says the jacket takes 1 hour to cut out the fabric, 4 hours to sew. The pair of pants takes 2 hours to cut the fabric, 2 hours to sew. And it says they have 20 hours for cutting fabric and 32 hours for sewing. And I know there's not 32 hours in the day. Why would they say there's 32 hours available? Anybody? Is there more than one person working, maybe? Yeah, so like combining up all their working hours, there's probably a few people working. And they give us some information about profit. Now, in A, it says let X represent the number of jackets and Y represent the number of pants. I told you what X and Y are. If I didn't tell you what X and Y were, where would you look for that information? The profit info, right? So here under profit, it says we have a profit on the jacket and profit on the pants. Since those are the two things I'm getting profit on, that is my variable. So let's skip down to profit. It's at the bottom. Let's skip down there real quick and let's write an equation for profit. All right, it's part D. We'll just get this part done since we're talking about it. Remember, for profit, we're going to say the profit of jeans and pants equals. How much did they say you get for a pair of jeans? 14. So we would write 14x. And how much for a pair of pants? 8 plus 8y. And there's your profit equation, okay, which we will come back and use in a few minutes. So yesterday we were crossing off the numbers as we used them. We used the 14, we used the 8. Now we are going to write this system of equations. And yesterday I said you don't have to make the table, but I'm going to make a table here just because I think it helps somebody. What goes across the top of my table if that's what you're making? Kayla? Topic. X and Y and total. Now my suggestion yesterday, if you have trouble coming up with your equations, is to think about what totals you're being given. What total numbers do they give you here? 20 hours for what? For cutting. Since I know that there's a total of 20 hours to cut the fabric, that's going to be one of my equations. Okay. What else do they give me the total for? Sewing, right? There's total of 32 hours to sew. So that's what the other equation is about. Since I give you an answer, I have to be able to fill in the rest of the info. All right, let's go back to the cutting fabric part. X was jackets. How long do they get to cut out a jacket? 1 hour. So I'm going to do 1x here in this first box. And how long does it take to cut out a pair of pants? 2 hours. So we did plus 2y. And what inequality symbol was going here with the 20? Less than or equal, because I can't use more than 20 hours. Good. One equation is done. All right. Sewing. How long does it take to sew a jacket? 4x plus how much for y? 2y. And again, I can't use more than 32 hours. So I'm almost done. What are the other two inequalities that I have to write down? Yeah. X is greater than or equal to 0. And y is greater than. Why do I have to put those? So can I have a negative number of pants and jackets? Okay. So what we have to do next, now that I've written my system, and I don't have room because I need to solve these graphs, but if you want, you can rewrite them. But those are my 4 equations. I need to graph all 4 of those, including x and y are greater than or equal to 0. These ones are easy. Let's graph those ones first, and then we'll solve the other ones for y. The x and the y greater than or equal to 0, those are just your x and your y axis. Okay, you're just going to put a line along the x-axis, that's y is greater than or equal to 0, and a line along your y-axis. I know that seems kind of silly. Why am I drawing a line on the axis here? But it might help visualize some of those feasible regions once we make them. Okay? Now, for the other 2 equations, you have to do a little bit of algebra. You need to solve the equations for y. Now, I know you don't need me to talk through, hopefully, too many of the steps for solving, so you can go ahead and do that on your own, but I'll write it up here as you go. So subtract the x. Okay, and then divide by 2. So I'll get y is less than or equal to 10 minus x over 2. And once you get that one, make sure when you graph, you plot as many points as you can. Okay. Don't just like plot the endpoints and connect, because these feasible regions with all the grids are going to get really sloppy really fast unless you're careful. And that took me all of like 2 seconds to plot those points. So just plot them, and then use your ruler to connect for that one. And then I'll solve the other equation. 4x plus 2y I know I'm not talking through this, but I think you're okay. You can check in a minute. I got 15 minus 2x for the other one. Alright, so minus 2, if I start at 15, would be down to right 1. Oh, that doesn't work. I messed up. What did I do wrong? Oh, 32. That would be my problem. I see. Right here. Oops. See, occasionally I mess up too. Like right now when I can't get my pen to work. Here we go. So that'd be 16 minus 2x. Does that sound better? Yes? Okay. Sounds better to me at least. There, and I knew I was wrong because my lines weren't crossing. That's a nice point. So that's a clue for you too. If you're graphing and you're not intersecting on a nice spot, you might have made your equation or your graph wrong. We good? So I'll let you finish up graphing here. Now, while you're doing that, let me ask you, how many lines did we graph? 4. So how many sides will your feasible region have? 4. Do you see a quadrilateral anywhere that could be bounded by all 4 lines? Casey?
Like in the corner.
This bottom corner here. This guy. It's kind of a goofy looking shape, but that is your feasible region. Okay. I saw some incorrect feasible regions on some quizzes when we turned them in. That's okay. We'll be more careful now. So from that feasible region, the rest of the process is like your quiz, only there's application to it. So you need to figure out for me, what are, I'm going to move this here. Yep, right at the bottom. What are the vertices of this feasible region? I'll start with the easy one, 0, 0. What's another vertex? What is it? 8, 0, okay. 0, 10. And the last one? 4, 8. So just like your quiz, what we're going to do, we all okay with those vertices? All right, what we're going to do is we're going to take each of those vertices and we're going to put them into our profit function. Now I'm going to speed this process up. We're going to at least all write the same thing to start here. We need to find the profit at 0, 0. That means 0 pants and 0 jackets, right? And then I need to find the profit for 8, 0. 8 pairs of jackets and 0 pairs of pants. 10, 0. Selling 10 jackets and 0 pants. And then 4, 8.
0, 10.
Yes, it would. I wrote it wrong. You're right. Maybe I shouldn't have made a video this period. I'm all kinds of mistakes here. Uh-oh. You know I'm better than this, guys. I'm letting you down. 4, 8. Okay, let's make this faster. So we don't have to write out every single one. Remember, let's do the 2 rows, or the first row by the window, do 0, 0. Second row here, that I'm standing in front with Charlie, that's Tyler, do 8, 0. Caden's row, do 0, 10. And these 2 do 4, 8. Alright, I'm saving you some time. So now I'll just write the work up here. I'm putting the X and Y in here. The first one should be really easy, so you lucked out. And then we'll go through them as a class. So just find your one. And then 14 times 4. Alright, first row, you should be good. I don't think you needed even a calculator for that one. What's the profit if I sell no jackets and no pants? $0. Alright, everyone else can just fill that in then. Write that on your paper. Second row, what's the profit for selling 8 jackets and no pants? How much? Second row, what was the profit here? 12, what? 112? Alright, there we go. $112. Third row, what's the profit from no jackets and 10 pairs of pants? $80. And the last row, 4 jackets and 8 pairs of pants? 120 sounds right to me. Double check here. 14 times 4 plus 8 times 8. 120. Okay. Which one is the maximum? 120. So this company will make a maximum profit. So make sure you write this part down. You'll make a maximum profit of $120 selling 4 jackets and 8 pants. Now you have to put the context behind it, otherwise the numbers mean nothing in an application. Okay? Not hard to put it together, just kind of correct. Alright, we have one more because the back one's a little bit different. So go ahead and flip over. We're going to talk about calculators. Now when I was in high school, we called our calculators, we didn't call them calculators. Apparently we thought we were cool, and we called them TIs because it's Texas Instruments as a brand. And our teachers called them TIs, everyone. And I think I've told you, like, no, we didn't have cell phones when I was in high school, so everyone played games on their calculators. Like, that was the cool thing to do, and, like, English teachers would confiscate them and all kinds of things. So I made a problem about TI calculators. So Texas Instrument makes a lot more calculators than this, but they make something called a TI-30X, which is just this basic little scientific one. And then they also have the TI-84s, right? Most of you have a TI-84. Long-term projections indicate an expected demand of 100 of these little TI-30s per day and 80 TI-84s each day. But there's a limitation. Because of the limitation on production capacity, meaning they can only make so many, they can't make more than 200 of these little calculators, and they can't make more than 170 of graphing calculators in a day. But they have a contract, and their contract says they have to ship at least 200 total calculators every day. Okay, so you have a lot of numbers there, a lot of words. Let's figure out what is x and y even going to be. So x equals y equals. Now where do we look to find x and y? Profit. Okay, so my profit is here. It says TI-30 calculator is a $2 loss, and the 84 is a $5 profit. Okay, so what do you want x to be? TI-30. I'm just going to call it a TI-30, not TI-30x. Yes, you.
I don't think you adopted B for the question.
What?
2B.
Okay, that's fine. Thank you. I wasn't. Okay. And y is going to be what? TI-84. Okay. You were like way ahead and off track there. Thank you. Okay, let's jump down to profit real quick. Let's do this one again first. Now, when I look at profit, I want you to watch the words up here. My profit is going to be very similar. P of x and y. Now, profit for x, the TI-30. What did I say the profit was there? A loss. How do I write mathematically a loss? -2. So these actually don't make TI very much money. Texas Instrument loses money there. How much do the 84s make them? Plus a positive $5 per TI-84. So what we're going to do is we need to come up with our system of inequalities. And this is going to be a little bit different than ones that we've done. So let me get all the words here, and we'll set up our table. Yes, I forgot to change the words, but I think we also know what we're supposed to do, right? All right, topic, x, y, total. All right, do you see a total? Read that through. Do you see a total given to you? Kayla?
2,000 calculators.
200 calculators, right? Yeah, so it says to satisfy the contract, they have a total of at least 200 calculators being shipped every day. That's a total, right? So let's put that number in, and let's figure out what would be like the topic of that equation. The number is shipped, right? The total to ship. Now, let's make that equation here. We did one like this yesterday. This was the corn and wheat problem yesterday. 200 is the total calculators, yes? So how do you think you'd write this equation? We're saying all the TI-30s and all the 84s have to be at least 200. Shout it out. X plus Y. Okay. Now, be careful on your inequality here because it says all the calculators has to be at least 200. So it's going to be greater than, more than or equal to 200. Okay, so that's one equation. The second one here is a little bit different. Do you see any other total number? No. What do you notice though? It says, so let's talk about the TI-30s. We have to make at least 100 TI-30s, but no more than 200. Right, so those kind of go together, right? Any way that you think you could put those together, it's going to be a little different. But,
100 is less than or equal to X is less than or equal to.
yeah. So this is a little bit different. This is going to be a compound inequality here. There's not going to be a total for this one. These are just two compound inequalities. I have to make more than 100, but less than 200. This is the total to make. So can you do a similar compound inequality for TI-84s? What's the minimum? 80. So 80 is less than or equal to Y. And what's the maximum you can make? 170. All right, does that make sense? I know I squeezed it in there a little bit. Okie doke. I'm sorry, what did you say?
It's the X.
X was the TI-30s.
The inequality.
Oh, 100 is less than or equal to X is less than or equal to 2. Okay, now, let's do the compound inequalities first. Let's talk about the X's. What kind of lines are going to be graphed at the 100 and the 200? What kind of line? Vertical or horizontal? Well, X is vertical. So you want to graph a vertical line. I'm going to make, what color? I'm going to use red here. I'm going to graph a vertical line at 100. X equals 100. And then I'm going to graph a vertical line at X equals 200 over here. That is your constraint. My TI-30s have to be in between those two vertical lines. Now, how about the 80 and 170? What kind of line is that going to be? A horizontal. So I'm going to graph a horizontal line at 80 and a horizontal line at 170. And finally, the last one, my slanted or oblique line, I'm going to solve. I'll leave it. So I'll have X plus Y, this is an easy one to solve, is greater than or equal to 200, and I have to subtract the X. Now, this is the first one where the scale's been not 1. Now the scale, we've made all the scales really nice on these grids. So even if I start here at 200, if I just follow the boxes like usual, down 1, over 1, that's the same slope. Since the scale is going by 10 on both axes. So down 10 over 10 is 1. So you can go ahead and plot all those points here. Be accurate. And then we'll connect lines. Now we graphed a lot of lines here. How many lines did we graph? 5. So I need a 5-sided region. Can you see where it is? In between 2 reds, 2 purple, or 3 purples then? Is that it, 3 purples? See how it's up here? Yes, now if you need to think about it, you're in between the reds, the 2 verticals, you're in between the 2 horizontals, and then we need it to be greater than above the slanted. And that fits all those criteria. You done, Hayden?
Yep.
Just write down.
Can I like stay here?
Sure.
There's a-
I'm almost done. Just you're distracting me. You're in the way. All right. Now, can we list our ordered pairs for our feasible region? What's one of them? 180? No.
120.
Oh, 120, 80. Yes. Okay. So we have 120, comma 80. Okay, what's another one? 100, 100. 200, comma 80.
200.
Yeah, 200, 170. And last one. 100, 170. All right, now let's speed this up like we did last time. Are we okay there? Yes, I don't want to rush you. Yes, Maddie.
Why don't we do the x squared equal to 0?
Oh, I forgot about that. Good question. Why did we not list these ordered pairs out this time? Anybody? Shout it out. Just say it. We kind of did it already, right? When we limit it at the lowest is 100 and the lowest is 80, that's obviously not negative, right? So we just have a higher, lower bound. Good question. Yeah, so we don't need these guys in this problem. Okay? So let's do what we did in the last problem. Let's write out all of our profits and then we'll divide it up by rows to evaluate. So the first row by the window, we'll find P of 120.80. The second row, we'll do a profit of 100, 100. Middle row, profit of 280. Row with Kayla will be, let's do 200, 170. And last row will be 100, 170. All right, so I'll give you a minute. So first row is first one. Second row with Charlie is 100, 100. Caden's row, 280. Then window by the wall, you go 100, 170. Just find yours. No need to do them all. They'll take all your time. So we don't need to spend all of it. Caden, are you meant to prepare yourself for your class? You can answer all the questions.
Yeah. I'm also probably going to forget.
I forget and I'll teach you 3 times. Alright, who by the window can tell me the profit for 120 TI-30s and 80 TI-84s? How much is it? Does your row agree? 160? Okay, so 160 for the first. So everyone can write that down. Next row here, what's the profit for 100 of each calculator? How much? 300? Do you guys agree your whole row agrees? Okay.
It's pretty simple.
Caden's row, what did you get for yours? 0. This one's interesting. So if you are selling 200, that's this point right here, and 200 of the 130s, or the little of the 30s, and 80 of the T84s, you make no money. That's this point right here. You break even, but you don't make a profit. 200, 170, top corner up there. What's right here? 450. Do you guys agree in that row? All right, row out the door. 650. I agree with that. I remember that number. All right, so we knew what makes the minimum profit. Who makes the most money here? Yeah, so if I have to sell 100 of the TI-30s and 170 of the TI-84s to get a max profit of $650 for that day. Well, this is like scaled down, right? So this is not like, you're not only making 170 calculators. They'd have to do that by hand. But